Okay, Gabrielle, I hope this video will help you. Now, your question, if I understood correctly, what I've done here is I've screenshot the video, the place at the video where you had a question. It's about 22:49, and we're just getting ready to get started with the cotangent of theta. Okay. Now, your email, you said you were confused about the cotangent ratio for the 3 square root of 7. Then you said 4 triangle. I wasn't sure what that meant right there. But, and so I'm gonna pick it up and just kind of redo this. The answer I gave you is correct. Okay, so let's go over this again. Now, first of all, there's an easier way to look at this. I guess I was trying to show you and all my students who watch this video, don't forget, you can always take a previous answer and flip it. Big word here, Gabrielle, if it helps or if it's faster. Okay, for example, if sine is 3, if the sine of an angle is 3/4, then flip it and the cosecant is 4/3. That's pretty fast. Sometimes flipping's faster, sometimes it's not. Okay, in this example here, flipping it's really not faster. I probably shouldn't have done it that way. Let me explain why, Gabrielle. As you know, hopefully, tangent and cotangent are inverses of each other. Thus, I can take the tangent of theta, which is this, I can flip it and put it here for my answer. But the problem with that is now I have a radical, square root of 7. And by the way, a radical is a square root, a cubed root, a fourth root. Any root is called a radical. This box here is called a radical. Okay, so we have a radical in the denominator, which is never allowed in higher level math. It's just not simplified. It's like giving an answer in middle school like this. 3/6. Well, you know that's not a good answer. You should reduce it, and your answer would be 1/2. Okay? And so, in higher level math, you never want to have radicals in your denominator, in your final answer. So, in this case here, in the notes I gave you, I told you to take this and flip it. And that's okay. And we're going to come back to that in a second. But probably in this case, the fastest way to have done this problem, instead of flipping it, would have been to simply say, okay, what is the ratio, what is the formula for cotangent? Well, it's, do you remember, it's adjacent over opposite. So, adjacent is, let me say that again, Gabrielle. The formula for tangent is opposite over adjacent. So the formula for cotangent would be adjacent over opposite. So your adjacent side goes up top. That's square root of 7. Your opposite side is 3. And look at that. Boom, you're done. There's your answer. Okay? So flipping is sometimes faster. Sometimes it's better to just go to the triangle and get your answer from that. Okay? Now, however, sometimes you have to flip, Gabrielle, because sometimes there's not a triangle to go by. Okay? So with that in mind, let's do this again. Hopefully it'll make sense. I'm going to find the cotangent of theta by flipping the tangent of theta. So if I flip this, I get 7 over 3 square root of 7. Now, I don't want this radical in the denominator. Okay, Gabrielle? Now, yes, I could multiply the top and the bottom by the entire denominator. But that's going to make it longer. I'm sorry, there should be a 7 right here. Sorry about that. I can take this entire denominator, put it here and here. But that's going to be a lot more math. That's not what you're supposed to do. You're supposed to look at the radical that you're trying to get rid of. In this case, it's right here, square root of 7, and that's what you put in the top in the bottom and you multiply it. Okay? Now that's legal to do, Gabrielle, because don't forget, anything over itself, like 5 over 5 really equals what? 1. 10 over 10 really equals what? 1. A million over a million really equals what? 1. So when I put square root of 7 over square root of 7, that's really 1. I'm really taking this fraction here times 1. So I'm not changing the value, right? I mean, you can multiply any number by 1 and it doesn't change the value. It might change what it looks like, but it doesn't change the value. So it's totally legal for me to multiply this fraction here by square root of 7 over square root of 7. Now, why did I pick square root of 7? Because that's what I'm trying to get rid of down here, okay? So, 7 times the square root of 7 is 7 square root of 7, okay? Now, this one's a little more complex. I mean, Gabrielle, look, if I just had square root of 7 times square root of 7, that would be 7. But I've got a 3 hanging out over here, okay? So it's a little more complex than that, okay? So I can say there's a 1 here. That's totally fine to do if there's no number here. 3 times 1 is 3. Inside number times inside number. Square root of 7 times square root of 7 is square root of 49. So when I have 3 square root of 49, Gabrielle, that's the same thing as 3 times the square root of 49, okay? Well, Gabrielle, you know the square root of 49 is 7, right? I mean, the square root of 49 equals 7. So, 3 times the square root of 49 is the same thing as 3 times 7, because the square root of 49 equals 7. Now 3 times 7 is 21, and there we go. Now, Gabrielle, pretend this was an 8 right here. Just pretend for a second it was an 8, okay? You could not reduce these two numbers here because nothing goes into them evenly, okay? But a lot of students then try to reduce these two numbers here. That is illegal. That is not equivalent. You can't do it. I'm not going to get into a proof right now why you can't do that, but trust me, you can't do that. Now, if it looked like this, you could definitely reduce the 7 and the 21 because they're both inside numbers, okay? But that's not the case. 21 is not under a radical like this, so you cannot reduce these two numbers here. You cannot reduce these because nothing goes into them, so you would be done, okay? But we don't have an 8 here, we have a 7, and 7 goes into both of these numbers. 7 goes into 7 once, 7 goes into 21 3 times. 1 square root of 7 is 1 square root of 7, and there's a 3 down here. Now, Gabrielle, if you put that for your final answer, no problem. If you don't want to put this 1, you don't have to. So this is a good answer, and so is this too. Okay? Gabrielle, I hope that helps. I kind of repeated what I said the first time, but that's the best way I can explain that, okay? Email if you have more questions. I will try to help some more.